Hello everyone, welcome back to today's video. So this is the daily episode of LeetCode Daily, and today we are maintaining the streak and solving the LeetCode question of the day, which is question 1015. Let me expand it for you. Here it is. So what does the question say? Smallest integer divisible by k. So here in this question we are given a positive integer k which will be included in the problem or in the input, and we need to find the length of the smallest positive integer n such that n is divisible by k and n only contains the digit 1. And then we have to return the length of n. If there is no such n, then we have to return -1, and n may not fit in a 64-bit signed integer. So what is happening here is, in this question, this might be a little complicated in the beginning, but let me try to make you understand, guys. So basically what is happening is, in this question we are trying to have an input which is k, first thing. Then what is happening is we have to find the length of the smallest positive integer n, and that n should only contain one. So it's like single one, double one, triple one. It's like that. Suppose here, like let's like do this here. So like one, maybe it is double one, triple one, maybe it is 4 times 1. So n is a number which can be any one, and if it is not, then it is returning -1. Suppose in this example, let's understand with the example. Suppose here suppose here we are given input k equals to 1, so the output is also 1. Why? The smallest answer is n equals to 1, which has length n. So with 1, only 1 is divisible, so the smallest answer is also n equals to 1, which has length 1. So we have to return the length of the number. So suppose here, if the length is if there are 4 ones, then we have to return the length 4. So the answer will be n equals to 4, the final output. So that is what we have to do, and we have to remember that if there it is 2, or if it is 5, then it is impossible to divide it. So that's why if it is 2 or 5, we will be leaving it, the return we will be returning -1, because if there is no such n, that means if there is no number of n ones which are divisible by the given input. So that is the thing. For example, here if the input is 2, k is 2, then the output is -1. Why? Because there is no such positive integer n divisible by 2. So there is no integer n divisible by 2, so we written -1. Similarly, in 3 there is like output is 3, because the smallest answer is n equals to triple one, which has length of 3. So triple one is divisible by 3. How can we do it? We can divide it simply. It's like 3 3s are 9, then remainder 2, then 1 carry over, 3 7s are 21. So triple one is divisible by 3. Here, like suppose if you are dividing, 1 divided by 3 equals to what? 21. But there's no positive integer by which n like 2 is divisible, so that's why it is returning -1. And same for 5. Same for k equals to 5, it will return n equals to -1. Why? Because there is no positive integer that is divisible by 5. Simple. So let's start with the question, and like the problem recap is simple. Like the number of only digit ones we have to find, and if no such number exists divisible by the given input which is k, then we return -1. Simple. And in this case we have to remember that if k has any factor 2 or 5, that means if it is 2 or 5 or any factor of 2 or 5, then answer is always 1 -1, sorry, because any number made only of ones is never divisible by 2 or 5. Why? Because any number, like either it is 1, or it is double one, or it is triple one, or it is 4 times 1, any number, like if you try to divide it in a calculator also, none of them are divisible by 1. Simple. So that's why we have to always keep in mind that if k equals to 2 or k equals to 5, then we have to return -1 intuitively, because that is the rule and that is the hidden concept behind it. So that is what we have to remember. Okay, now the key idea behind is this: we cannot actually form a very large number, like suppose 1 1 1 1 1 1 1 1, like it can be infinite, because if we are forming a list of only ones, then it can be a very large number. So what we will be using is, we will be working with remainders, and we will be using pigeonhole principle. If you can google it also, you can find out more about it in detail, but now we will be focusing on question solving itself. So what is this pigeonhole principle? We will be taking remainders. We will be taking a remainder num n, and then we will be dividing the number n, whatever n like input, and we will be dividing it by the input k, the number n, and we will be trying to find the remainder. and for 1 the length equals to 1, and similarly we will be adding it. So that's how we are going to do it. Now I know you guys are getting confused, so let me start writing the code and you guys can understand it along the way. I will help you explain also, and also you can code it along the way also. That's why I will be coding with you guys itself. Let's expand the screen. Let me expand it. Here it is. Let me remove this comment. Here. So now I will be writing a Java code. And what I will be doing is, as I told you guys, if it is 2 or 5 or any factor, if k has any factor as 2 or 5 also, then we can't take that number in our consideration. In the beginning itself it returns -1, which is because any number of made of only ones, that means 1 11 111 11,000 1111, whatever number made of only ones is never divisible by 2 or 5 or any number which has factors as 2 or 5. So that is why we are gonna keep this condition in a if statement. So let's do it. I hope you guys are able to hear me clearly. So if k remainder, that means mod, basically if we are finding the remainder, this thing, and k mod 5, if both of them are equals to 0 or either of them are equals to 0, then what we are gonna return? We are gonna return -1. So what we are gonna return -1. That is the first thing that you guys have to remember. If many people like miss this thing itself and then they miss the question itself. That's why it's a medium level question. If this condition would not have been there, maybe it would have been categorized as a easy level question. Now let's have a variable which is rem, basically remainder. It's because the series of ones can be very large, so we will be working on remainders and trying to find it in the most case steps possible, which is a pigeonhole principle. So now let's run a for loop for this. For int length equals to 1 and length less than equal to k, what we are doing is we are running a for loop by initializing, then providing a condition, and then incrementing it, putting an increment operator, post increment operator, if you guys have studied the basics. Here it is like the length of ones, and the length of one should be less than the input provided, which is k, and then length plus plus, that means less than or equal to, basically. Now inside the for loop we will be writing the real code which will build the next 111 series. So it will be rem equals, which is remainder, wait a minute, yeah, remainder equals remainder multiplied 10 plus 1, 10 plus 1, remainder of 2, remainder of k. So here what we are gonna doing, we are like the building the series of ones through this function where it is multiplied by 10 and then added to 1, basically 1, then 1 plus 10 11, then 11 plus 11 into 10 plus 1, 11 to 10 110 plus 1 111, and then we are dividing it by k to find the number of ones. So that is what we are doing. Like here, like if I put a comment, I can like tell you guys, like if it is like 1, then if we multiply it by 10, what will be there? It will be 10. If we add 1 to it, then what it will be? It will be 11. Similarly, if we multiply 11, like it is a continuous process, right? So we multiply 11 by 10, what it will be? 110. Then if we add 1 to it, then what it will be? 111. So it is like a series of ones, like here you can see 11, 111, and then so on and so forth, basically. So that is what we are doing. Here we have already like wrote this thing, and now we are going to like write a if statement to return the length if the remainder is 0. So if remainder equals to 0, return length and semicolon here. And now if it doesn't, like if these conditions not satisfied, then return -1 for sure. Return -1. That means if it is returning -1, that means it is never divisible. Like if suppose if it like there are three conditions basically. In the beginning we are putting a condition if the input k is either a factor of 2 or a factor of 5, then it should return -1. Then this condition here in between the series of ones, and then again a condition of returning -1. That means it is not working here also, it does not satisfy this statement also. Then the final, it is never divisible, so that is -1. So that is what we are doing. And here return length is what we are finding, the return the smallest length that we have to return basically. So now let's run this. Yeah, we are able to run this thing. Now let me submit it, guys. Okay, so we have submitted it. We have got a good time complexity. Let me show you the time complexity and all. Just give me a second. So here's the time complexity. So 2 millisecond beats 97.52%, and we have passed all the test cases. Hope you guys are able to understand the question. I will put the link of the question in the description box. Along with that, let me maximize this thing. So if even if you're watching on a mobile phone, you can take a screenshot of it, and this is the explanation of this statement, so you guys can understand how is the series going. 1, then 11, then 111. Okay, so let's meet tomorrow for the streak of the day. Thank you.